Now, let's work on our special case when two variables are eliminated at the same time. Okay, so let's start with step number 1 to number each equation. So we have 1 here, equation 2 here, and equation 3 here. Okay, so our first step is to pick two equations and eliminate one variable. But in this case, it happens that we will end up eliminating not one variable, but two variables. Okay, let's see which variable we want to eliminate. Notice that for the first problem, we eliminate the y because this was ready to eliminate. This is negative, this is positive, so it was ready to eliminate. Let's see if we have a similar case in problem number 2. And it happens that we do have a similar case. Notice here, we have x in the first equation, and we have a minus x in our third equation. So we could pick equation 1 and equation 3 and eliminate x. Okay? And notice as well, x is positive here, x is negative here. Z is negative in the first equation, and z is positive in the third equation. So the x and the z will cancel at the same time. So let's pick equation 1 and equation 3. Okay, so equation 1 is x minus y minus z equals 0. And equation 3 minus x plus 2y plus z equals 1. Notice that in this case, we are ready to eliminate variables because this x is positive, this x is negative. So we don't have to multiply by anything else to change it. Therefore, this x with this negative x will cancel. And let's combine the y values. Have negative 1y plus 2y. It's going to be 1y or simply y. Now notice the z's, like I mentioned before. Minus z plus z will already cancel. So I'll be left with equals 0 plus 1. That will give me 1. So we already solved for one of the variables. Now what happens if we solve for one of the variables in our first step? Then our next step, meaning step number 2 for this special case, is to substitute the y value into two equations. It could be any equation from here. It could be either 1 or 2, but you have to choose 2, okay? Let's pick, I don't know, notice equation 1 has too many negatives. It could be tedious to work with, but not that difficult. It's up to you which equations do you want to choose. It doesn't really matter at the end. Let's pick equation 1 and equation 2 for now. Again, it doesn't really matter which equations do you want to substitute the y value, as long as you pick two equations, okay? So let's see equation 1. So for equation 1, I'm going to have x minus y, but y is 1 minus z equals 0. Now let's rewrite this equation in the general form, meaning leave the variables in the left side and move the numbers into the other side. So only leave the letters in the left side and the numbers on the other side. Notice I have a number in the left side. So let me move this negative 1 onto the other side in order to leave only x and z in this side. So 1 is subtracting, so the opposite will be adding. So this cancels. And I'm going to be left with x minus z equals 0 plus 1 is 1. So now my equation 1 becomes x minus z equals 1 after substituting y for 1, because that's the value we got in the previous step. Now, for equation, we say 2, let's substitute the y value again. We're going to have 2x minus 3y. But what is y? Y is 1 plus 2z equals 7. Now let's do the operation here. Negative 3 times 1. Now give me minus 3 plus 2z equals 7. Again, let's rewrite it in the general form. Let's leave the variables in the left side and the numbers to the other side. So that means I need to move these 3 to the other side. So it's subtracting, so the opposite will be adding to both sides. So this cancels right here, and I'm left with 2x plus 2z equals positive 10, because 7 plus 3 gives me 10. So now notice here, in this equation, I have 2 here, I have 2 here, and I have 10 here. All of these numbers are factors of 2. So what I could do here is I could reduce the equation by 2. I could divide each term by 2. And notice what's going to happen. Remember, I could do this because every single coefficient, meaning the number in front of the variable, and that number is a factor of 2. These 2, and then this 10. Okay? So I'm going to have x plus z, because 2 divided by 2 is 1, or the 2 cancels, I'm left with x. Same thing for z, equals 10 divided by 2, that will give me 5. Now, this becomes my equation 5, and the previous step becomes my equation 4. Now, the next step is to get equation 4 and equation 5 and eliminate one variable in order to solve for the other variable already. So that'll be step 3. So let me rewrite equation 4 and let me rewrite equation 5, which we reduce by 2, okay? Now notice here, we could easily eliminate the z already because I have negative z here and then I have a positive z here. So I could already combine them. So x plus x, that will give me 2x. Negative z plus z cancels, equals 1 plus 5, that will give me 6. Now from here, now we can solve for x. All I have to do is divide it by 2 both sides, and x will be 6 divided by 2, positive 3. Remember, positive divided by a positive gives me a positive number. Now we have solved for y, we have solved for x. Step 4 is to solve for the remaining variable or letter. Okay, so we could use either equation 4 or 5. Okay, so we can use either 4 or 5 to solve for, we are missing z, right? Because we solve for y, solve for x, so we're missing z. Notice equation 5, everything is positive, so that will be a little bit easier to work with. So let me rewrite it. So let's use 5. So I have x plus z equals 5. So I already have x. All I have to do is to substitute the x for 3 and bring the rest and solve for z. That means I need to move the 3 to the other side in order to leave the z. So it will be minus 3, cancel here, and we are left with z equals 5 minus 3 equals 2. So we already solved for x, for y, and for z. So our solution will be x, which is 3, y, which is 1, and z, which is 2. That will be our final solution.